Hello everyone, happy Tuesday. Today's target is to balance level 2 equations. Before we get into today's lesson, I want to take a little bit of time and just kind of go over what we'll be doing this week and what you can kind of expect for this week. Today is level 2 equations, tomorrow is level 3 equations. Thursday, it's just a practice day. So I'll either have practice problems for you in a video format with the Edpuzzle or some kind of a Google Doc via the Google Classroom. Thursday will just be a practice and review day. Friday, we will have a quiz, about 10 questions, the same length as all the other quizzes we have been doing. And that's kind of the plan for this week. Next week, we're going to be getting into a unit known as Stoichiometry. And I'm going to be changing that unit up a little bit. With that particular unit, the primary topic is going to be around a project where we will create some kind of a food or dish or bake or cook or whatever floats your boat. So go ahead and you can start kind of thinking about that. What kinds of things would you like to cook in our stoichiometry unit? It's a very broad cooking unit in terms of what kind of materials you'll get to use. It's kind of what your family wants for dinner maybe, or something that you'd like to make. I'm very flexible on what it is that you end up cooking for you and your family. And I'll tell you how that relates to stoichiometry when we get there on Monday. Okay, first things first, let's learn today's target. Level 2 equations. This is actually a level 1 equation. This was the equation that I gave you guys as an exit slip yesterday. And I learned a couple of very important things from that exit slip. Firstly, I figured out that most people understood how to use the element bank because they were getting the right number of magnesium and chlorine and hydrogen on both sides of the equation. Great, you guys are using that element bank. I'm glad that's helpful. We're going to continue using that. However, the way that many people chose to balance this problem was wrong. See, some people chose to change the subscripts, and we can't change the subscripts. Subscripts are these little numbers right here. You cannot change subscripts, and you cannot add subscripts, and you cannot take subscripts away. And so I saw a lot of people do something like this, where they had H2Cl2. Well, that's wrong. You can't do that. H2Cl2 is a different molecule than HCl. HCl is hydrogen monochloride, or hydrochloric acid. This is dihydrogen dichloride. It's a completely different molecule with completely different properties, and it does not exist in the context of this problem. Don't change the subscripts. Okay, so for those of you that did change the subscripts, how do we actually solve this problem? Well, we do what you did originally, and a lot of you did it correctly. We count the number of atoms on both the reactant side and the product side of our equation. There we go. Cool. Once again, notice how I'm putting my magnesiums in the same spots, my chlorines in the same spots. All of my atoms are in the same place on both sides. It's just going to help in terms of organization so you don't get numbers and letters mixed up. All right, 1 magnesium, 2 chlorine, 2 hydrogen. 1 magnesium, 1 hydrogen, and 1 chlorine. Fantastic. So we can immediately see, thanks to our element bank, that we need 1 more hydrogen and 1 more chlorine on our product side. So in order to do that, we're going to add an extra HCl. Because this is different than H2Cl2. This is 2HCl. See, we can't change, add, or remove subscripts, but we can add coefficients. A coefficient is just telling us how many of a particular molecule is in a particular problem. Okay. So when we add the coefficient 2 right here, well, now we've got 2 hydrogen. Here, I can just erase that. There we go. 2 hydrogen and 2 chlorine. And we have a balanced chemical equation. All right, So this is what I would call a level 1 equation. Level 1 equations, we're only adding 1 or 2 or 3 coefficients. Level 2 equations, we'll be adding 3 or 4 coefficients. And there's also going to be a little bit of a twist to some of the level 2 problems that we do today. Okay, here's our first main problem for today. It's not too bad. You'll notice it only has 2 different elements in this particular problem, which is kind of nice. One of the tricky parts about this problem is the oxygen. So it's very easy to make mistakes in this problem because the oxygen is in multiple places, and so we need to take that into account whenever we're counting atoms. And so people often make mistakes because they'll count one of these places and forget the other. Okay. All right, so real quick, let's start this problem off. How many iron, or Fe, do I have on my reactants and product side, and how many oxygen do I have on my reactants and product side? So I've got 2 Fe, I've got 1, 2, 3 oxygen, I've got 1 Fe, and 1, 2, 3 oxygen. So this is going to be a little bit frustrating for some of you because it's going to feel like we're always taking 1 step forward and 2 steps back. And that's one of the tricky parts about level 2 equations. You're not always going to take a direct path there. Sometimes you're going to make other parts of the equation messy in order to make certain parts work. And I'll show you what I mean by that. Our oxygen right now is balanced, great. But our Fe, our iron, is not. So in order to get the Fe to be the same on both sides, what do we need to do? Cool. So let's add another FeO. And now we've got 2 Fe, but now we've got 4 oxygen. And that's what I'm telling you. It's okay that our oxygen isn't balanced now because something else in the equation is balanced and we are closer to balancing the entire equation because of that move. All right, so our oxygens aren't balanced. We're going to need 1 more oxygen on our reactant side. How can we get 1 more oxygen on our reactant side? Cool, let's add another Fe2O. So now I've got 1, 2, 3, 4 Fe. And this is a place where a lot of people make mistakes. They'll say 1, 2 oxygen, and they'll forget we have 2 more over here. So we actually have 1, 2, 3, 4 oxygen. All right, great. Our oxygen is balanced. Unfortunately, the iron, the Fe, is not. So we're going to need more FeO. Remember, you can't just add Fe. You can't change the subscripts. You can't just make up something that didn't exist before. You can only add things that were already there. I can't add Fe, but I can add FeO. There we go. So now we've got 4 Fe's, 4 irons, and we've got 1, 2, 3, 4, 5, 6 oxygens. Great. Now I just need to balance my oxygen. Oh, forgot to change this. That's a 4. There we go. Now we just need to balance our oxygen. So I need 2 more oxygen on my reactant side. How can I get 2 more oxygen on my reactant side? What if I add another O2? If I do that, now I've got 6 oxygen on both sides. I've got 4 Fe on both sides, and now my equation is balanced. Last thing I need to do is what? What's the last thing we need to do in order to balance this problem? Good. We need to add our coefficients. We've got 2 Fe2O, 2 O2, 4 FeO. And we can get rid of these extra ones because Mr. Hempstead doesn't like it when it's super messy. Personal preference. It just looks better. Cool. There we go. A balanced chemical equation. Let's go over one more problem that is a level 2. Here we go. Okie dokie, folks. Welcome back. Go ahead, take a moment and jot down what I put up on the board. Get the unbalanced chemical equation, get the element bank, and then fill in your own element bank. How many arsenic, how many sodium, how many oxygen, how many hydrogen do we have in our reactants and products side of this equation? Then we'll go over it. Right. So we've got one arsenic atom on our reactant side, one sodium, one oxygen, and one hydrogen. Not too bad. Okay, on our product side, we've got 3 sodium. We've got 1 arsenic, 4 oxygen, and 2 hydrogen. Fantastic. All right, so the arsenic is already balanced. That's nice. One of the challenging things that you're going to run into with level 2 equations is it can be difficult to see where do you start. A great recommendation that I have is just start on the left side of the equation and work your way across. So since our arsenic is balanced, let's move on to the next one, Na, sodium. So I've got 1 Na on my reactant side, and I've got 3 Na on my product side. All right, so I need to balance that. How can I get more Na on my reactant side? Cool. So in order to get more Na on my reactant side, I'm just going to add more NaOH. Remember, we can't just add 2 more NAs. We must add something that already existed on our reactant side. Okay, so we've got 3 Na, we've got 3 oxygen, and 3 hydrogen. Solid. Nice. Okay. So now that our NaOHs are balanced, we're going to need, oh shoot, sorry. Small little typo. This should be a 3. My bad. Let's just go back to the beginning. Okie dokie, folks. Take a quick minute and jot down this unbalanced chemical equation as well as this here element bank. Go ahead and figure out how many of these different elements we have on our reactant side and our product side once you've finished writing it down in your notes. Let's go over it and see if you're right. So we've got 1 arsenic atom, we've got 1 sodium atom, we've got 1 oxygen atom, and 1 hydrogen atom on the reactant side. On our product side, we've got 3 Na, 1 As, 3 O, and 2 H. Cool. All right, so it can be a little tricky with level 2 problems in terms of deciding where do we start? What step do we do in order to start balancing this problem? And let me give you guys just a little bit of a step in the right direction. So if we just start on the left side, our arsenic is balanced. So that first one is good, ready to go. Let's move on to the next element, Na. Okay, Na, we've got 1 Na and 3 Na, not balanced. All right, so how do we balance the Na? How do we balance the sodium or the Na in this problem? Good. We're going to add more NaOH. Remember, we can't just add Na. You have to add things that already existed. So we can't just add Na, but we can add more NaOH. So now we have 3 Na, we've got 3 oxygen, we've got 3 hydrogen. Beautiful. Okay, sodium is balanced, arsenic is balanced. Love it. Oxygen, 1, 2, 3 oxygens, 1, 2, 3 oxygens. Oxygens are also good to go, but the hydrogens, 1, 2, 3 hydrogens, and 1, 2 hydrogens. So this can flummox people a little bit, because if I add more H2 over here, then I'm going to have too much H. I'll show you. If I add another H2, now I'll have 4 hydrogen and 3 hydrogen. So it's still not balanced. But what I can do is I can just say, okay, if I don't quite have enough hydrogen with that side originally, I can just add some more. And then if I need more hydrogen over here, I can just add some more. And now my hydrogens are good to go. A common mistake that people make is they forget to include these NAs and these Os. So let's just quick fix those. There we go. Cool. All right. Boy, now what? Now what should we do? Yeah, okay, I see what you're saying. We need to balance our sodium and our oxygen. So if I've got 3 Na and 3 oxygen right here, if I create another one of these compounds, another one of these molecules, now I'm going to have 6 sodium, 2 arsenic, and 6 oxygen. That step is a place where people are going to have a little bit of a difficulty making that jump. That's where we're honestly starting to get close to a level 3 problem, is doing something like that. The reason we have to do that is because we had 4 sodium on our reactant side. And we need to have more sodium on our product side. If I didn't have a second one of these sodium arsenate compounds, there would only be 3. I need more. I need 4 or more. Okay, so now we've got 6 sodium on this side, but we've only got 4 over here. So how do we get 6 sodium on that side? Well, we just add more NaOH. All right. 6 Na, 6 oxygen, and 6 hydrogen. Cool. All right. So now that our sodium is balanced, let's just take a quick second and see what's not balanced. So the arsenic isn't balanced. Well, that's fairly easy. I can just add 1 more arsenic. Great. Now my arsenic is balanced. My sodium is balanced. My oxygen is balanced. But the hydrogen isn't. 6 hydrogen and 4 hydrogen. So what I can do is I can add 1 more H2. And now my equation's balanced. All I need to do is just write in my coefficients. So we've got 2 AS. We've got 1, 2, 3, 4, 5, 6 NaOH. We've got 2 Na3ASO3, and we've got 3 H2. Cool. I'm just going to get rid of all these extra ones just so that it looks nice. And we have a balanced chemical equation. This is a pretty difficult problem. We are not going to be doing problems that are more challenging than this one that you saw right here. And we are going to be working on a very similar target tomorrow. There's not much of a difference between level 2 and level 3 balancing equation problems. You're then going to get more practice on Thursday working with level 2 and level 3 problems. So don't worry if this isn't making sense right at this exact moment. You are going to get more opportunities for more practice so that you can hit this target and be successful. As always, if you have any questions, shoot me an email, send me a message in the Google Hangouts chat page, or give me a call. I love it when students talk to me. I've had a lot of great conversations thus far. join us. All right. See you guys next time.